This problem is quite a bit more involved than the other problems that we've done so far. There's a lot to consider as we try to find the maximum value of g of x in this problem. Maximums, minimums, they occur at critical numbers. That doesn't mean every critical number yields a maximum or minimum, but it does mean that if there is a maximum or a minimum, it will occur at a critical number or at an endpoint. When we look at the domain of this, 3x e to the negative x, we know that x doesn't cause any problems. And e to the negative x, which is 1 over e to the x, well, e to the x will never equal 0. So e to the negative x will never equal 0. We won't have issues there. To find the critical numbers occur whenever g prime of x is undefined or is equal to 0. So that's our first goal. First goal is to identify where g prime of x is undefined or where it's equal to 0. So let's go ahead and find g prime of x now. G prime of x using the product rule will be 3x first times the derivative of the second, which would be negative e to the negative x, plus the second, e to the negative x, times the derivative of the first, which would be just times 3. Cleaning that up, we can factor out an e to the negative x and a 3, so we have 3e to the negative x times the quantity negative x plus 1. This is never undefined, so we can forget about that part, and equals 0 when x equals 1. Now there are a lot of people who would stop there and they would say, okay, the answer is x equals 1, and if it's multiple choice, you can be sure that that's going to be represented. One of the concerns here is that we have not necessarily determined that this is a maximum value. We've just identified that it's a critical number. One way to identify that it is a maximum or a minimum is we could do a quick evaluation, breaking up the number line into values of x that are less than 1 and values of x that are greater than 1. And we can do a quick test. Let's say we chose 0 on this side of 1, and let's say we tested x equals 2 on this side of 1. Let's go ahead and look at g prime of x. And g prime of 0, plugging it back into here, we get 3e to the negative 0, 3e to the 0 is 1, and times minus 0 plus 1, we end up with 3. But I don't really care that it's 3, I just care that it is positive. And if it's positive, that means that g of x is increasing. On the other side, if we evaluate this, let me highlight that, g prime of x at 2, I get 3 e to the negative 2 times negative 2 plus 1. Well, e to the negative 2 is going to be a non-negative 0, or number. It's going to be a positive number. Negative 2 plus 1, on the other hand, is going to be a negative number, and I know that'll be negative there, which means that our function is decreasing. And anytime we go from increasing to decreasing at a critical number, it means we have a maximum there. And I'm going to say maximum when x equals 1, because we're still not done with this problem. That's an important number, x equals 1, but it doesn't answer the question, what is the maximum value of g of x? It just tells you when that maximum value happens. So the last thing we would need to do here is we would need to evaluate g of 1. And going back to our original problem, we see that g of 1 will be 3 times 1 times e to the negative first power, or 3 over e. And that should be our answer.